Next up, we have Michael Dukes, the Director of Underwater Engineering for Consor Engineers. They're going to talk about the I-95 over Great PD River, catching the piers being attacked by channel migration.
Appreciate it, Dick. We have myself, Director of Underwater Engineering Services for Consor Engineers, work with state agencies around the country to help ensure NBIS metrics, and also respond to lots of natural disasters from different flood events over the years. With me is going to be Jeff Rowe. He was more involved on the design side of these repairs. He's our President of Structural Assessment, so he deals with all aspects of bridge inspection for Consor all around the country. We have a booth if there are any questions that we can't get to after the presentation or any additional information you'd like to know. We'd love to talk to you throughout the event this week. So first, we're going to cover the channel migration, how we monitor that over time, first through NBIS inspections, then all the way up to daily and multi-time per day inspections during specific flood events and meetings we had with the DOTs, the bridge owners over time to talk about why the problem was as severe as we felt it was and what the action was afterwards to keep I-95 open. So John yesterday was speaking about the Arch Bridge over the PD River up in North Carolina. We joke around once it crosses the South Carolina border, it becomes the Great PD River. So little comedy there. Most of the time, or portions of this river are straight, portions of it do meander. Right around the I-95 bridge is one of those meandering portions of it. And if we know anything about meandering rivers, they really want to get to the ocean faster, so they try to punch through and straighten themselves out. If you can see, which you don't, my cursor there, this river flows from the top left of the screen down over to the bottom right. So through that meander, it's wanting to cut off kind of that northwest corner just upstream of the top bridge and then punch through right at our lower bridge. The lower bridge on this image is I-95 northbound, has about 22% truck traffic in this area, quite a long detour route because there's just not that many roads through this rural part of South Carolina, just northeast of Florence. So we'll see, thankfully, before we had our drones in operation that really help us monitor and observe embankments and overall conditions looking up and downstream. Google was kind enough to start taking historical photos back into the 90s. We've seen through some other presentations this week. But here we'll keep that red edge of channel from 1994 shown throughout time so we can see how this river's moved. Once we jump ahead just over a decade, you can see where we're already starting to lose some of that channel on the northern section just upstream of that upper bridge. One of our first indications that river's trying to straighten itself out. October 2009, nothing really of interest has happened. A little more material loss there. We're starting to see some infilling on that lazy bend inside of the river between the two bridges on the left there, even getting itself more vegetated. Jump ahead to January 15. There's some historic flooding in the fall of 2015 in South Carolina, but also some events in late 14, early 15. And this is where we see the first migration to the northeast on our northbound bridge there, delineated by the now light blue channel profile. So that's when we first started realizing, hey, we're starting to see this migration that's going to be a concern as we move forward. We're going to want to keep an eye on this during future high water events. October 2017, like I mentioned, the fall of 15 had some additional flooding, only a little more movement just downstream of our bridge. But once again, that channel's trying to punch through kind of from our top left to straighten itself out and get rid of these bends in the river. Fast forward to the event that drove our repairs that we're going to be talking about today. Hurricane Florence came through and really walloped the entire Great PD River Basin through the eastern, northeastern portion of South Carolina and even into eastern North Carolina. Had tons of flooding, responded, I think, to 300 or so bridges we worked with South Carolina and North Carolina DOTs to do post-flood assessments, ranging from culverts, washed out roadways, and then the big attention getter was I-95 that Jeff will dive into a little deeper when we really realized exactly how much that channel started moving during this storm event. As you can see, all the bridge approaches to the main channel span completely flood, as floodplains do, during high water events. So after that one, what happened here? 1994 channel, we've lost a ton more material upstream of the southbound bridge at the top, and we've moved quite a bit further to the northeast. This photo is actually post some of our initial repairs, but that's just showing you how aggressively that channel's moving over under time. Before Florence in January of 18, so that would be kind of just before this flood event, that blue line is right around where Pier M is on your left. And after Hurricane Florence, our channel had jumped over another, I think, 65 feet to the northeast there, putting Pier M, that had, for the life of it, been mostly in the floodplain, monitored during routine inspections, and we finally started seeing it get into the channel around the 2016, 2018 ballpark on the NBIS underwater inspections, to now being fully in the channel. Not only fully in the channel, it was now undermined about 10 feet high as well. So we can see the thalweg is really aggressively moving to the northeast. We got about 25-ish foot long timber treated piles underneath there. While they were monitoring it, they started getting sounding data showing that it might be undermined. So then we brought in our acoustic imaging to verify the extent of that undermining, see some of the debris in there so we could really get a handle on exactly how much scour we were seeing at that location. Just a sneak peek, it kept moving even after we got repairs in place that Jeff's going to talk about. As you can see now, Pier L is in the channel, also undermined today, but finally have some crutch vents in place. But why did we care so much about it moving over? The approach is, bridge is pretty flat, no real elevation changes on the structure itself. It's not a navigable waterway, so we're not really considered too much about traffic moving up and downstream. Originally, that channel was around Piers N and O, off to the southwest in our original picture. But if we zoom in here, that kind of sand-colored line is our original ground line that I tried to highlight there. So you can see over Pier N is the last pier in this blown-up section. It was originally in the channel. Pier M was out of the channel. And LKH and all those were just in the floodplain. Never really thought that they'd be in the channel. And if you look at our footing elevations from Pier N to Pier M, we're about 10 feet higher. Now Pier M, reminds you, is in the channel after Florence. Pier M to L, elevations go up another 10 feet for those footings. So it's not just an issue of our channel dropping like we would see with general scour, but with that migration, now we're migrating towards footings that are at higher elevations and starting to undermine those. So that's where Jeff came in on the design side, started having some high-level meetings with the DOT, figure out what can we do to stabilize I-95 and keep it open to that vital truck traffic route.
Thank you, Michael. So we've been monitoring this bridge, as we said, for a while. In fact, the DOT actually installed a camera on the southbound lane looking at the northbound lane. And so as the rains of Hurricane Florence fell, DOT and I were monitoring that through that camera. Of course, as we saw the water come up, the embankments disappear in that picture and the floodplain reveals. And so there was concern of what's going on underwater. But as we also looked at the projections, the concern was how high was that water going to get? This was a historic flooding that took place in northern South Carolina and even in North Carolina that took place following Hurricane Florence there. And the projections were that the water was going to get up into the steel of I-95. And so we actually worked with the DOT to shut I-95 down, afraid that that bridge may be impacted from the water into the superstructure. As the bridge was shut down, fortunately the water crested below where they predicted it, and it only got slightly up into the superstructure. We were monitoring the channel bottom, and that's when we discovered that 65 feet of the channel had disappeared in a matter of days. That was concern because we weren't really sure what was going on with Pier M until we really got the acoustic imaging out there and were able to determine it. And so immediately the DOT was like, we need to do some repairs to this, and we need to have some repairs for it. The challenge was another hurricane was on the way. Hurricane Michael came through, dumped more water into the basin. We lost 60 feet. We were concerned. And so we actually closed a lane and set up a 6-hour monitoring as the floodwaters came up during that. I got to spend time out there. Every 6 hours, the alarm clock would go off. You'd go out, take your measurements to make sure that we weren't losing more bank and potentially losing portions of the substructure. So that was a concern. This river is very dynamic and controls a lot of basin. But as we looked at what can we do, And ultimately, we're going to spend some time talking about the crutch vents. But we first started with, what do we need to handle here? And so we were looking at repair options. We were looking at material availability. You know, this is before the supply chain issues that we have today. You know, what can we get? And then also, what can we do construction-wise? Some of the initial concepts were just on the back of a napkin here, really, or a little paper. Maybe we put in some sort of a cofferdam system and be able to pump concrete around that footing at Pier M. We quickly realized that that was probably impractical with the water level adjusting, the high flow that was against it. That was impractical. And so we settled into the fact that crutch vents were really our only option. This not only helped us at Pier M, but as we talk about and have seen, the channel continues to migrate, even in an accelerated pace. And so we wanted to be able to restore. So initial focus was on Pier M. We quickly decided that we needed to also do it at Pier L, which was on the bank at the time. And as Michael showed, it continues to migrate, and now it's in the channel. So as we looked at some of the designs, we had some scour analysis showing the prediction of the scour that was well below the pile tips of these piers that were not designed to be in the waterway. We ran through various models using FB Pier and even a STAD model to look at this, look at the dynamic loading that was on this, look at the lateral loading that was on this, to be able to come up with the design. That initial design was immediately shot down by the contractor. The material was not easily available. And so we were back to the drawing board, sort of, where they said, what can we get? They found some pipe pile down in Louisiana that they could get fairly quickly. And so we changed our design to be able to accommodate that availability. We then looked at the superstructure, or the cross members that we needed, the horizontal beams there that we needed. And that was very challenging to get that steel in short order. And so fortunately, the contractor had just demolished a bridge, US 301, had that steel sitting in the yard. And so members of our team went out, looked at it, we talked with them and said, yes, this could be a possibility. So we modified our design to accommodate the steel that was there that they had available. Able to sister a couple of these together, created two cross beams there that were used at the crutch vents to be able to model this and use it or design it appropriately. Fortunately, the fabrication, they were able to find good sections of these beams to be able to use. We're able to fabricate them, clean them all up, paint them, and have them ready for installation. The problem came in the construction. As Michael showed you, this is in a floodplain. The floodplain is over a mile wide. There is an access road coming on along the northbound lanes, right there to the south, kind of the lower part of the picture, that the contractor said, we'll walk the crane out, put it on a barge, and be able to use that to construct the crutch vents. The issue is, this is the Great PD. The Great PD goes up, the Great PD goes down. And you can see in a matter of days, it shoots up in excess and down in excess of 30 feet. Being able to construct in that type of environment of up and down is very challenging for the contractor to be able to do it. And particularly the access road would be overtopped, would be flooded. Time and time again, they would start out trying to get out there and get their equipment and all the material, and all of a sudden the water would come back up and it would wash away. So you would go from situations that you see in the upper left there, over the roadway, to coming back to finding as the water retreated, your road completely washed out. I think they rebuilt this access road 7 times in order to be able to get out there. The problem is, once the water went down and stayed down, you would arrive at the river, and now you had sandbars that you had to work around to get in. And so the contractor struggled immensely to be able to get this large barge, large crane, out onto the waterway. No practical access upriver or downriver to be able to get there to that. But eventually, he was able to get the barge on the waterway with the equipment and with the material to start the construction. Fairly straightforward with construction in the sense that we set up a template. They set up a template to be able to drive the piles. The challenge was that we wanted to limit the overall size of this, as we had to design it to the material that we had, and therefore the pipe piles were located fairly close to the road itself. And so therefore lanes were shut down as we were driving these piles, not to impact the traveling public. Augered out the inside of the piles to a certain depth, and then finished up with driving the pipe piles to the required tip elevations, some 120 feet below the water line there. It became very challenging how to install the cross beams. We initially thought that they could do that from the deck of the roadway. Realized real quickly that the capacity of the bridge did not have that to be able to set these. So they used a crane on the barge to be able to set these and put these in place. Lots of maneuvering to be able to set these cross beams underneath the bridge itself. You can see here just the close proximity of the cross beams, 2 of them for each bent or for each pier, to the edge of the roadway there, and the installation that took place. These cross beams were put up snug. There were bearings there put up snug, and the entire crutch bent is designed to take the entire load of the bridge in the event that the pier fails. As we look here today, look at the end of the initial construction there. Both Piers M and L had crunch bents installed. And as we can see here, after the installation of Pier L, which is in the foreground here, the channel continued to migrate, and now Pier L was completely engulfed in the river itself. Michael?
As Jeff mentioned, we wanted to keep the profile of these repairs as streamlined as possible, even with the pipe piles in place. Still turned into quite the debris catcher, so we get quite a bit of timber caught up on there. But then there was also some concern with Pier L now being undermined, its footing at even higher elevation. Its timber piles now exposed that had never been looked at. Our most recent underwater inspection wanted to check the condition of the original pier along with the pipe piles. So we took an underwater timber resistance drill, went under the footing, and tested, I think, 8 piles, or did timber resistance drilling measurements on 8 of the piles to determine the physical condition, make sure they weren't decayed or rotted out. Actually all the piles we tested ended up being in good condition, only very minor void on the very core of 1 or 2 piles that we tested there. So still have some confidence in the condition of the foundation from those original piers, but as Jeff mentioned and I've talked about, that channel still wants to straighten itself out. We didn't stop the channel from moving, but DOT made the decision as well to stabilize the next 4 piers inland so that during future flood events, as that channel continues to migrate, we can have confidence that 95 northbound right there is still stable and that we have pier crutchments in place to keep those piers stable, the bridge open to traffic. We're also now starting to look at the southbound bridge as that channel continues to move around and how it's affecting those foundations. The foundation plan alignment is not the same on the southbound as it is for the northbound. So we have some deeper foundations in different locations, but we are starting to more closely monitor that migration up on the northwest side as it approaches the bridge there. And we have a plan in place with these to be able to catch those if the same type of migration starts happening there. So with that, love to field any questions about the site that any of you may have about our repairs.
Thank you. First of all, it was a great presentation. My question is, as you're looking around at the scour and trying to evaluate foundations you didn't even touch, was there a possibility of live bed scour over there, and were you able to determine? As you know, sometimes in certain rivers it fills back in, and you go there and you measure down to the top of the soil, but the soil beneath it for a number of feet is not trustworthy. And in terms of determining the adequacy of the foundations, that's a consideration. So did you have that situation, and how did you evaluate it?
Very good question, yeah, because we know that the most scour takes place at the highest flood event, and so we were monitoring right at the crest of the flooding during Florence, and we felt that we had a fairly accurate understanding of where the channel bottom was. As we conduct underwater inspections, obviously not during the flooding event, we do probe to be able to understand that. But to your point, in the design, we totally discounted any kind of contribution from the existing piers or the current piers so that the crutch bents would take the entire capacity of the bridge itself. Because of that issue, we were concerned that there could be infilling that would not be adequate for that.
I figured that for the crutch bends, but some of the other piers that are close to that area, I assume you evaluated those as well and determined that you didn't need to touch them because there was no live bed scour and there was adequate amount of soil left to support the bridge, right?
Correct. So Pier M, which was 10 feet above the channel piers, is supported by crunch bent, and then the remaining 5 beyond that are supported fully by crutch bents. Piers N through O and P, which were in the original channel, were lower foundations and didn't have the undermining that was associated here at Pier M. So Pier M through 6 piers are completely supported by crutch bents now that would be affected by that. Pier O and Pier P are completely on the southern bank now. They're completely dry.
Hey, did y'all look at actually trying to mitigate the migration at all as far as using something, I don't know, riprap, or is the scale too big for this channel?
Very good question. Yes, that ran through it. In fact, I don't have a picture of this, but in the early 2000s, when I first started doing the underwater inspection of this, the DOT had actually used some mitigation. It's the first time and the last time I've ever seen this, where they took car chassis, tied them together, and placed them on this north bank embankment. Those disappeared. But to your point, this is a very dynamic, it has a very steep incline coming out of the Thalwag to the embankment. In fact, the contractor installed some sheet piling along the embankment at Pier L because it was still on the bank when they installed the crutch bent, and it completely disappeared the next time. And so the mitigation that would be required, the environmental impact and evaluation, was well beyond what the DOT wanted to tackle at this point. These bridges will be programmed in the future. I don't think they currently are programmed in the future for replacement. They're fairly narrow, and at some point they will be programmed in the future. So we're just buying some time until that can take the place.
Was there any consideration to, if it scours to where the existing bent fails, that it does not fall into the crutch bends?
So very good question on that. As the channel continued to migrate, particularly we were concerned about Pier L, because we feel that we have very little embedment in that. There were some discussions of putting some tilt meters on that in order to be able to monitor that over time and see if that's the case. However, it was ultimately decided that we would just monitor that, and if there is a need, then the DOT can come in there and have a removal. The cost was pretty high to be able to come in there proactively and do that. And so the choice was not to do that at this point. But yes, it was definitely a consideration.
Thank you very much. They are.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.